Hello everyone, welcome back to my YouTube channel. Myself Kavana and studying first year CSE in Sri Venkateshwara College of Engineering. Today I am going to explain computing error and approximation. In that we are going to see introduction to computing error, type of errors, source of errors, rounding errors, approximation techniques, error analysis in algorithms, forward and backward error, condition number, error propagation. Computing error and approximation. Introduction to computing error. Computing error is the difference between the true value and the computed value. Understanding error in numerical methods and algorithms. This presentation will expose various type of errors and this in computing. Type of errors. These are two main categories of errors, absolute and relative errors. Absolute errors measures the difference in value without normalization. Relative errors produce a measure of errors in relation to the true value. Absolute error. Absolute error is calculated as the absolute difference between the true value and the approximated value. It is expressed mathematically as true value minus approximated value. An absolute error produces a direct measure of closeness to the true value. It is expressed mathematically as true value minus approximated value. Relative value. Relative error. Relative error is the ratio of absolute error to the true value. It is calculated using the formula true value minus approximated value divided by true value. This measure for the error size relative to the magnitude of the true value. It is calculated using the formula true value minus approximated value divided by true value. Source of errors. Errors can arise from various sources including measurement and limitations. Rounding errors occurs when numbers are rounded to fix within the limits. Rounding errors. Rounding errors occurs when a number is approximated to a certain number of decimal places. These errors can especially in iterative computations. Rounding errors occurs when a number is approximated to a certain number of decimal places. Approximation technique. Various exist to approximate functions. This method aims to reduce errors, will be producing effective computations. Polynomial construct construct A that passes through a given set of points. However, higher degree polynomials can lead to accelerates and known as polynomial phenomenon. Error analysis in algorithms. Errors analysis is essential for the performance of numerical algorithms. It involves estimating both errors. Proper error analysis can guide improvements in algorithm designs and implementations. Error analysis is essential for the performance of numerical algorithms. Forward and backward errors. Forward errors refers to the error in which computed results compared to the true value. Backward errors. How much the input could need to change for the computed results to be exist. Both measure produce in fact into the relativable of numerical solutions. Difference between forward and backward errors. Forward errors refers to the error in the computed result compared to the true value. Backward errors occurs how much the input could needs to change for the computed results to be exist. Condition number. The condition number of a function measures how sensitive the output is to change in input. A high condition number indicates that small changes in input can result in larger changes in output. This property is critical for understanding the stability of numerical algorithms. The condition numbers of a function measures how sensitive the output is to changes in input. A high condition number indicates that small changes in input can result in large changes in output. This property is critical for understanding the stability of numerical algorithms. Condition refers to how a function changes with respect to small changes in its inputs. Functions that change when their inputs or stability can be problematic for specific computation because rounding errors is as input can result in large changes in the output. This property is critical for understanding the stability of numerical algorithms. The error will be compound further the numerical errors in the invention process itself. Error propagation. Errors propagation. How errors in input value affects the output values. It is essential in input step calculations where errors can accumulate. Technique such as sensitive analysis help in understanding and errors propagation. How errors in input values affects the accuracy of output values. It is essential in multi-steps multiplications where errors can accumulate. Errors approximation. Thank you.